Hi guys, a while ago I have published a video about TT systems and how if you have one of those all-in-one inverters, you could use the dry contact to create a non-permanent neutral to ground bond in the case you want to be off-grid but still want to use the grid as a backup, that the inverter can use its grid bypass feature. This we had to study these Chinese manuals here. Every manufacturer has the same manual and they are completely identical with every manufacturer. This was translated once probably from Chinese to English, and it's not always very easy to read. And there was, unfortunately, I was a little bit too quick in reading this as well. And I made a mistake by interpreting this table about the status of the dry contact. And yeah, one viewer of mine, he also got confused when he was looking at this and kind of found out that there's a little bit contrary situations here when you compare different modes, etc. And this, yes, was my original mistake, because I found a very satisfactory status right on the top here, which was perfectly fitting to our situation. I did not look exactly into those following mode dependent relay statuses there. And yeah, but this I should have done more carefully, and we have to correct and take a really precise look into this, because otherwise this is not working as we want. First of all, let's take a look how these inverters internally work. We have a couple of connections on the down of these all-in-one inverters. One is AC in, one is AC out. We have a battery connector, we have a PV input. What we are interested mostly about AC bonding, neutral to ground bonding, is of course how does the AC system work in these inverters. And we have essentially two paths for the AC going through this device. So one is a path where AC converts to DC and then the DC again to AC. That is via an internal AC to DC converter or a charger. Then we have our 48 volt or 24 if you have a 24 volt version DC main bus, and from there it's again a DC to AC inverter to create our AC out. But in parallel we also have a shortcut, and that shortcut is our grid bypass relay. So whenever we cannot go the path 1, the inverter will switch over to its alternative path, and that is the grid bypass relay. So this one, the AC-DC to AC path, is a galvanically separated path. We are turning our AC into DC, DC into AC. The AC in this case, or the utility if you want to call it like that, does not see what is the state at the AC out because of the galvanical separation in between. So in this case, any bonding on the AC out, as long as you go this path, would not be seen by the utility anyways. But now the problem is when the inverter goes into the grid bypass and just closes simple relays. Now the utility side is just brought into the AC out. Now of course any manipulation on this side is seen on the grid side as well. So this is important to understand the modes of the inverter and why some modes we will see will not be suitable to use the dry contact to create an automatic bond. This is now our famous table which led to the confusion. In the last video I just said, okay, we have power off. We want to open our neutral to ground bond via the dry contact, so we want to have an open dry contact there. Then we had the line output is powered from utility, and that was what led me think just, okay, whenever the output is powered by utility, the opposite is the output is powered by the battery. So this would kind of mirror the bypass relay, but that's actually not true. The bypass relay is different by logic than the dry contact. So we need to exactly look into the modes of the inverter to know what is actually going on the dry contact. So that's why I wrote here mode lost, right? This only applies if the output is powered by the utility, if the modes kind of fail or cannot keep up with the parameters, then it's a kind of simple fallback onto the utility by opening the bypass relay. The inverter itself cannot run on utility by not using modes. So whenever you turn on the inverter and it is working, it will enter modes. And what do we have here? We have 4 different modes to choose. The first one is a simple UPS mode, an uninterruptible power supply. When we have battery, the grid goes down, the inverter will start producing our AC, and when the grid comes back on, it will charge its battery up again, and that's it. Just wait for the next grid outage. So in the utility mode or UPS mode, however you want to call it, as the word says, the power comes from the utility direct and only from the utility, as long utility is available. So now it would depend which path of our 2 options that AC is coming from, and I'm highly suspecting that it will be the easy one, the second path, just by open bypass relay, right? And when the utility is gone, the AC would come from the battery. But in this case, in the TT system, we cannot make a bond. So we just do not have the information from the dry contact where the energy is coming from. But now come those modes which you probably were thinking about to use. We have 3 modes, which is SBU, then SUB and the SOL. I have now divided this SBU, SUB and the solar mode, and the reason is that here for our bonding purpose, the SBU and SUB mode, they will actually not be suitable. Why it's not suitable? The reason is that, as I said before, in those 2 modes, utility will help out the inverter through the AC to DC converter charger. And in the normal case, grid bypass would never be switched. So even if battery falls below the low limit or then comes back to the high limit, the grid bypass was never engaged in this case. We have a state change of the dry contact, but actually we would always need a closed dry contact, because the power, the AC, always comes from the inverter itself. But if you look now, closed, this is also similar to this and this state of the inverter. In the case that this mode fails, the inverter would revert back to the simple utility mode, let's say like that, where it just opens the bypass, and then we have the same state. So we would, if we follow this recommendation here to use the normally closed contact, then we would actually be in the same state as when the inverter goes really on utility or it is shut down. So that's not what we want, and we can't really do anything about it. Let's look at this SOL mode, the solar only mode. In this mode we have the absolute same dry contact configuration, but they have a different meaning. So in the solar mode, reaching the low battery alarm also means an automatic switch to bypass. So the dry contact position is clearly defined by the state of the battery, if it should be open or if it should be closed. And once the bypass is switched by the battery state, it does not really change here on this one. Even these two states are the same again, right? Because now we have really a defined operation of the inverter switching to the utility. So in the normal case, the inverter will have to use the normally closed contact for our bonding relay. So last time I told you to use the normally open because we went from that point there. But this is different now. We should actually use the other contact. In the normal operation we will always be here, but this is also the case when the inverter would switch either in the simple bypass mode because it lost all the modes, or it would be powered off. As I said, 99.99% of time this would just fit perfectly still. But can we do anything about those cases where you maybe have to manually shut down the unit? And yes, there is a way, and this I want to show you now. I always told you when we are talking about using such all-in-one inverters, always use it together in combination with a transfer switch. And in this case it is very important to use a transfer switch which also have dry contact on it, right? So this model here, this is a model which is sold on many online web stores. AliExpress definitely have it, probably you can get it also on Amazon or something. These are the modern DIN rail transfer switches, and they have two dry contacts here, also one for the primary source and one for the secondary source. So you can also here, when you have the transfer switch, when it's on the primary source, source A, you can also choose, do you want a signal from the normally closed or normally open contact. Why would we need this? Well, as I said, you should always use a transfer switch when you're using such inverters, and this is how this would look like. So you have your utility supply, one goes to the inverter, and from the inverter out to the primary source of the transfer switch, and one goes from utility direct to the secondary source. So whenever the inverter fails or you shut it down because you want to do some maintenance, the transfer switch would either automatically jump to the secondary source, or you can also transfer it manually. But now we have the chance of using another set of dry contacts to tell our bonding relay what to do. So on the inverter We are using the dry contact given by the mode we want to use. So most probably, as I told you, recommendation is to use the SOL mode. If you have a solar application for your all-in-one inverter, for this you just choose the dry contact of the inverter which is needed for that case, and additionally that wire which goes to the coil of the relay, bonding relay, also has to go through the second dry contact which is on the transfer switch. That one will be typically the normally closed relay of the primary source. So whenever the transfer switch is away of its primary source, because the inverter completely fails, it shuts down, right? Then that dry contact will open, and it does not matter where you now have these contacts, what this contact of the inverter says. Even this one is closed now, the signal to the relay is still to open. And this is the trick how we can now get this open even when the inverter would command a close. Having the bonding relay be commanded by the SOL mode here on these two positions, which are set by the battery status, and then also switch this status here by the transfer switch dry contact, we can actually cover probably almost any case that the bonding relay, bonding situation is then in the correct position. As you see, unfortunately not as straightforward and easy as I meant it would be in the first video, but still, so if you are using the correct mode and you carefully read how those modes work, you can find an acceptable solution for automatic bonding. Then of course you can also use these voltage settings to create a sort of optimal switch over, change over of when the inverter is on the grid and not on the grid, and etc., to kind of create a good solution. Sorry for this, I have to read manuals more carefully. I also belong to the generation already who does not read manuals. I hope I could clarify this now, and yeah, it's all about yourself to decide how you want to do this in your particular case. So thank you for watching this video. Please comment again, like the video, subscribe to the channel, and I see you next time.